Hi, I'm Pat Hartigan. I'm a professor of physics and astronomy at Rice University. And I'm using the Hubble Space Telescope to make movies of collimated supersonic jets from young stars. Well, astronomers have been trying to understand how stars form for centuries. And we sort of have the basic idea down in the sense that there are these large areas of gas and dust, which astronomers call molecular clouds, and out of those, small areas will tend to collapse under the influence of gravity. And the result of that is then a star that's surrounded by some sort of a disk, which can sometimes actually form planets and give you solar systems. But that's really not the end of the story, in the sense that what we found is, in the last couple of decades, is that these objects actually have winds and outflows in jets, which then can, in fact, affect the surrounding environment. So there's feedback. And so what we've been trying to do, this is clearly a dynamical process. If you think about it, we're only getting a snapshot of it. What we would really love to do would be able to follow that process and actually watch these stars form, in real time. But we can't do that because it takes 100,000 years or something for one of these things to actually collapse and form a star. And so what we have been able to do, though, now with these new Hubble Space Telescope images, is to actually observe some of these outflows in real time, because these objects are close enough and the actual outflow speeds, which are supersonic, so they're very, very fast, and they go out and create shock waves and those sorts of things. Those things are going fast enough that we can actually watch how these things change in real time. So what we've done with the Hubble Space Telescope is we've taken images at multiple times, and then we stitched them together in order to try to basically make a movie. In terms of actually interpreting these data, it's a lot like the difference between simply looking, say, at a picture of a football game, of, say, a quarterback throwing a pass, versus actually seeing the entire play. So with a single picture, we could kind of make up anything that we want to at some level. With the actual data and with the actual movies, we can see how things are developing. Just like if you were to look at the picture of a football player throwing the football, you don't know what happens in the play later, because you just see them back, ready to throw the pass, and you don't know what's actually happening. And now, since we've been able to see a little bit of this, at least, we get a better idea as to how things are developing.